The use of single-phase and three-phase receptacles with similar plugs in an enclosure is not permitted according to the National Electrical Code. Placing receptacles with different voltage ratings and different phase configurations in close proximity creates a potential hazard. Individuals may mistakenly interchange the cords, resulting in unsafe or damaging operation of the equipment. The prohibition against using different receptacles with similar plugs is found in NEC 406.7d, which states receptacles of different voltage ratings shall not be installed in the same box unless the receptacle is part of a listed assembly for use with more than one voltage rating. Furthermore, NEC 406.8 C states receptacles of different phase configurations shall not be installed in the same box unless the receptacle is part of a listed assembly for use with more than one phase configuration. Interchanging the cords could lead to several dangerous scenarios. Firstly, single-phase operation of the three-phase equipment. This can damage the equipment or create a hazardous condition. Secondly, overloading of the single-phase receptacle. The single-phase equipment may draw a higher current than the receptacle is rated for, potentially causing overheating and fire. Thirdly, injury to personnel. If the cords are reversed, individuals could be exposed to dangerous levels of voltage or electrical shock. To eliminate the safety hazard, you should take certain steps. Firstly, label the receptacles clearly. Use permanent labels to indicate the voltage and phase configuration of each receptacle. Secondly, use different plug configurations. Choose plugs that are not compatible with each other to prevent accidental interchanges. Thirdly, consider a listed assembly. If possible, use a listed assembly specifically designed for multiple voltage and phase configurations. A deeper dive into NEC 406.7d reveals further implications. The term listed assembly is crucial. It means that the combination of receptacles in a single box must be evaluated and approved by a recognized testing laboratory such as Underwriters Laboratories UL or Intertech ETL. This ensures that the assembly meets specific safety standards for handling multiple voltages. The listing process involves rigorous testing to verify that the receptacles are properly insulated, that there are adequate barriers to prevent accidental contact between different voltage circuits, and that the assembly is properly labeled with clear warnings. Without this listing, the installation violates the code and poses a significant safety risk. Similarly, NEC 406.8 C addresses the dangers of mixing phase configurations. A three-phase receptacle uses 3 energized conductors, while a single-phase receptacle uses only 2. If a three-phase plug is mistakenly inserted into a single-phase receptacle, it can result in an imbalance of current and potential damage to the equipment. The code recognizes that certain specialized assemblies are designed to handle multiple phase configurations safely. These assemblies typically include features such as polarized receptacles, which prevent the insertion of incorrect plugs, and internal wiring configurations that ensure proper phase balancing. Again, the key is that the assembly must be listed by a recognized testing laboratory to ensure compliance with safety standards. Beyond the specific code requirements, there are several practical considerations to keep in mind when dealing with mixed voltage and phase configurations. One important factor is the location of the receptacles. If receptacles with different voltage or phase configurations are installed in close proximity, it increases the likelihood of accidental interchanges. Ideally, receptacles with different characteristics should be physically separated to minimize the risk of confusion. Another important consideration is the training of personnel who will be using the equipment. Employees should be thoroughly trained on the proper use of each receptacle and plug, and they should be made aware of the potential hazards of interchanging cords. Training should include clear instructions on how to identify the correct receptacle for each piece of equipment, as well as the consequences of using the wrong receptacle. Regular refresher training can help to reinforce these concepts and ensure that employees remain vigilant about safety. In addition to labeling the receptacles with voltage and phase information, it may also be helpful to color code the receptacles and plugs. Different colors can be used to designate different voltage levels or phase configurations, making it easier for personnel to quickly identify the correct receptacle for each piece of equipment. For example, A common practice is to use blue receptacles for 120-volt circuits and red receptacles for 208 volts or 240-volt circuits. However, it's important to note that there is no universally standardized color coding system, so it's essential to clearly communicate the meaning of each color to all personnel. Furthermore, the use of different plug configurations is a crucial safety measure. Plugs are designed with specific shapes and pin arrangements to prevent them from being inserted into receptacles with different voltage or phase configurations. For example, a standard 120 volts plug has two flat blades and a round grounding pin, while a 208 volts or 240 volts plug may have angled blades or a different pin arrangement. By using plugs that are not compatible with each other, you can significantly reduce the risk of accidental interchanges. When selecting plugs and receptacles, it's important to ensure that they are properly rated for the voltage and current requirements of the equipment. The voltage rating of the receptacle should match the voltage of the circuit, and the current rating of the receptacle should be sufficient to handle the maximum current drawn by the equipment. Using undersized receptacles or plugs can lead to overheating, electrical shock, and fire hazards. In some cases, it may be necessary to use specialized receptacles and plugs that are designed for specific applications. For example, there are receptacles that are specifically designed for use with GFCI ground fault circuit interrupter protection, and there are plugs that are designed to be waterproof or explosion-proof. When selecting these specialized receptacles and plugs, it's important to ensure that they are compatible with the existing wiring system and that they meet all applicable safety standards. Another option to consider is the use of permanently wired connections instead of receptacles and plugs. Permanently wired connections eliminate the risk of accidental interchanges as there are no plugs to be inserted into the wrong receptacles. However, permanently wired connections also make it more difficult to move or reconfigure equipment, so this option may not be suitable for all applications. If you do choose to use permanently wired connections, it's important to ensure that the wiring is properly installed and that it meets all applicable code requirements. The conductors must be sized appropriately for the current requirements of the equipment, and they must be properly protected from physical damage. The connections must be made in a junction box or other approved enclosure, and the enclosure must be properly grounded. In addition to following the NEC requirements, it's also important to consult with a qualified electrical contractor or engineer to ensure that the installation is safe and compliant. A qualified professional can assess the specific needs of your application and recommend the best solutions for your situation. They can also help you to identify any potential hazards and develop strategies to mitigate those hazards. When working with electrical equipment, it's always important to prioritize safety. Electricity can be dangerous, and even a small mistake can have serious consequences. By following the NEC requirements, using appropriate equipment, and consulting with qualified professionals, you can help to ensure that your electrical installation is safe and reliable. Consider a scenario where a filling machine requires 230 volts three-phase power, while an elevator operates on 208 volts single-phase power. Both are housed in the same enclosure and use similar-looking plugs. Without proper precautions, a worker could easily plug the filling machine into the 208-volt single-phase receptacle, causing the machine to operate improperly or sustain damage. Conversely, plugging the elevator into the 230-volt three-phase receptacle could overload the single-phase motor, leading to overheating and potential fire. The NEC guidelines aim to prevent such scenarios by mandating clear separation and distinct configurations for different voltage and phase systems. This is particularly critical in industrial settings where various types of equipment are used, and the risk of misconnection is higher. The NEC also requires that all electrical work be performed by qualified individuals who are trained to understand and follow the code. This helps to ensure that installations are done correctly and safely, minimizing the risk of electrical hazards. When evaluating an existing installation, it's important to look for any signs of non-compliance with the NEC. This could include the use of improper receptacles or plugs, the lack of clear labeling, or any other conditions that could create a safety hazard. If you find any such issues, it's important to take corrective action immediately to bring the installation into compliance with the code. This may involve replacing receptacles or plugs, adding labels, or making other modifications to the wiring system. The goal is to create a safe and reliable electrical system that protects people and property from the hazards of electricity. Moreover, electrical safety is not just a matter of following the NEC. It also involves adopting safe work practices and using appropriate personal protective equipment (PPE). When working on electrical equipment, it's important to always energize the circuit before starting any work. This means turning off the power at the breaker or disconnect switch and verifying that the circuit is dead using a voltage tester. You should also wear appropriate PPE such as insulated gloves and safety glasses to protect yourself from electrical shock and other hazards. In addition, it's important to be aware of the potential hazards of arc flash. Arc flash is a dangerous phenomenon that can occur when there is a short circuit in an electrical system. It can produce extremely high temperatures and pressures, as well as intense light and sound. Arc flash can cause serious burns, blindness, hearing loss, and even death. To protect yourself from arc flash, you should wear appropriate arc-rated clothing and use arc flash barriers when working on energized equipment. The NEC provides detailed requirements for arc flash hazard assessments and for the selection of appropriate PPE. These requirements are based on the results of an arc flash study, which is a detailed analysis of the electrical system to determine the potential arc flash hazards. The arc flash study takes into account factors such as the voltage, current, and clearing time of the circuit. Based on the results of the study, the NEC requires that the equipment be labeled with information about the arc flash hazard, including the arc flash boundary and the required PPE. By following these requirements, you can significantly reduce the risk of arc flash injuries. The electrical code is a living document that is constantly evolving to reflect changes in technology and best practices. The NEC is updated every 3 years, and each new edition incorporates changes and revisions to the code. It's important to stay up to date on the latest edition of the NEC and to understand how the changes may affect your electrical installations. You can access the NEC online or through a variety of publications and training courses. In addition, many local jurisdictions have their own electrical codes that are based on the NEC. It's important to be familiar with the local codes in your area and to ensure that your electrical installations comply with both the NEC and the local codes. Finally, remember that electrical safety is a shared responsibility. Everyone who works with electrical equipment has a responsibility to follow safe work practices and to report any potential hazards. By working together, we can create a safer and more reliable electrical environment for everyone.